All right, so this is our Bash and Git study group. As I mentioned to those before I started the recording, something that would be good to follow along with is in the homeroom, I've linked our study group repo here. This is basically where all future study group notes will go. So I think I'll probably update them weekly because yeah, I'll update them probably weekly, and then any new notebooks for study groups will be added here, and I'll like try my best to keep them as organized as possible. But basically, there's a bunch of instruction on how to use this repo, and I'll be walking through what all of this means in a little bit. Before I begin, some things I want to highlight. I keep forgetting to mention, but in our cohort Slack channel, there are actually a couple of technical coaches, Ben Jacobson and Matt Spar. If you've seen them saying like, hi, happy Sunday, or like happy Friday, they are actually there as support during non-office hours. So they are usually there on the weekends and also in the later evenings. And so they're there to answer your questions. So if you see that they're online, and usually they'll say that they're online by saying like happy whatever day it is, feel free to ask them questions. They can also hop onto Zoom calls if you ever need to like talk through something that you're working on. I keep forgetting to mention them as a resource, but yeah, in case anyone's curious as to who those guys are, that's who they are. Let's see, what else I have to talk about? Oh, before I get into material as well, a couple event highlights. Tomorrow, there's actually going to be a couple events. At noon, there's going to be an intro to career services. This event is not just our cohort, but also the full-time cohort that started on the same day. So if you're just curious as to like, what career services at Flatiron School is all about, they'll be introducing themselves and what they do and how they're going to aid you in your job search when you're nearing the end of the program. That will also be recorded. So I'll send out a recording link because I know it's like noontime and not all of you can make it at that time. Also, something that I highly recommend that you go to, Dara is hosting an office hours in the evening at 7 p.m. Eastern. She also posted a message about it in Slack. The two students who are speaking there are actually my students from my current other cohort that are like gonna finish in the next few weeks. So I think it'd be a really good opportunity to hear from them and have them talk about their experiences over their past 10 months, especially as you're beginning your 10 months journey too. And then finally on Monday, there's going to be a final project showcase. So this happens like roughly once a month. It's just like a few projects from software engineering and data science, and it's their like capstone projects. You don't have to go to this every month, but I think it's like a cool opportunity to see, what your final projects will look like, or like what are the things that some of the students end up building when they're at the end of their program. So yeah, just something that I wanted to highlight. Let's see, I wrote a list of things this time so I don't forget. Okay, yeah, that's all that I had before I start material. Any questions about any of these events, feel free to let me know. All right, so to get started, with Git, I'm going to be walking through two processes that we're going to be using Git over the course of this program. First, I'm going to like get into more detail on like what is actually happening when you're forking and cloning a lab and like working on it, and what does that mean with like, the lab on your computer versus the lab on GitHub. And then I'll talk about this study group repo as well and how we're going to use it and interact with it. So to start, I know we talked about cloning a little bit before, but I wanted to get into more detail. So I'm going to use just a random lab as an example. So this is just like an introduction to strings lab, just to use an example. And a couple things to note here. I mentioned this before, but I wanted to make sure that you know where to find this, the solutions. The solutions to any lab exists as a branch here. So when you click onto the little OctoCat logo here, you're brought to this GitHub page, and you can find the solution for any lab that has a solution under branches. We'll get to working with branches a little bit more with the project, so I will save that explanation for later. But as you can see, when I switch to the solution branch, it's kind of just like a slightly different version of the repo, right? It's just the lab with the solutions. Interestingly, this is not typically how branches are used in real life. Just for some context, branches are used in real life to do like version control. So let's say I'm working on a project and the project has like is mostly done, and I wanted to work on this one specific part of the project. Usually what people do is they will make a new branch, and what making a new branch does is it makes a copy of everything. So you have this duplicate on a new branch, and then you can work on this new part on this new branch. And the purpose of doing that is such that, you know, you can work on these new changes to make sure that they work first before applying it to the master or main branch. So you can, it's sort of like, you know, just making sure that something works before you actually get it in production or put it in play. So that's usually what a branch is used for. For our purposes, for our curriculum, it so happens that a branch allows us to house our solutions as well. But that process of like, you know, working with a project, we'll actually be doing that, not with our first project, but one of the later projects, I'll get you all to start working with branches as well, just so, you know, we can slowly ramp up what we do with Git. All right, so that's branches. So let's just go back to the master branch. Don't forget that when you want to clone a lab, you should always fork the lab. I'll talk a little bit more about like what forking does, but main thing you can see here, this repository, and a repository is basically a folder that has all of your stuff. This repository is owned by Learn Co-Curriculum, which is our curriculum team. When you fork it over, it basically creates a copy of the entire repository, which means that, you know, all of its files and all of its branches as well, onto your own GitHub account, just so you have a version. And the copy, it's a copy of like, you know, that current state of that repository. So you can see here now, even on my personal account, I also have the solution. So all the branches are copied over as well. So after you fork it, usually what you do is now you can clone the lab and start working on it locally if you like. So just an example, don't forget to copy the HTTPS link. Basically SSH, if anyone is familiar with SSH, it just means that it's like you need like some encrypted password thing to access it. So HTTPS is good enough here. Copy this, and then in your terminal, just decide where you want to save this lab. So just as an example, this is how I used to save my labs when I was a student. Again, this is my Mac terminal, but very, very similar on a Git Bash on a PC. So I have a DS folder, and in that DS folder, I have a labs folder. Because this is my work computer and not the computer I used when I was a student, I don't have too many labs. So if I do ls, which lists all of the folders that you have here, I don't have too many labs here. You could potentially even do like phase 1, 2, 3, 4, 5. If you want to put it by topics, you can do that too. So with labs, let's say I just want to put this lab here. I'm just going to do git clone, paste that HTTPS link, and now that DSC strings lab is there. It's on my local computer. Very, very important that you fork it, and I'll show you all why in a little bit. So now that I've cloned this lab, let's say I want to work on it. Oops, Jupyter Notebook. So typing this in, it launches Jupyter, and I can work on my strings lab here. So just as an example, I'm just gonna run some cells. Let's see what's something that I can run. All right, so sentence here, and then just to show that, you know, we're making a change here. Sentence plus more exclamation points there. So let's just say this is me completing the lab. One way of just, you know, making sure that all your files are up to date is let's save this and, you know, assume that we're done with the lab here. We can close this out. I like to always shut down my notebooks just because, I don't know, maybe OCD, but I like to shut down my notebooks, and I quit out of Jupyter Notebook here. By the way, it's Control-C for those of you who don't know. Control-C shuts down your Jupyter Notebook, and then my lab is done. On here, the lab actually shows that it's not done yet. So if I go into index.ipymb, which is the actual notebook file that you use, hopefully it loads up. Sometimes it takes a little bit. You can see that these haven't been updated yet. If you want to save a copy of your completed lab on GitHub, which is, you can sort of treat it like, I don't know, like a cloud server for all of your labs. If you want to do that, all you have to do is add, commit, and push your changes. So let me just clear this out so it's neater, and let's zoom in a little bit more. Oops. All right. So if you want to add, commit, and push a specific lab's changes, you would have to go into the specific lab. Let's see, what's it called? Strings. So now I'm in the strings lab. One thing that you should always do, and I always do as a precaution, is do Git Status. So doing Git Status basically tells you, the status of your files. And once I did Git Status here, you see that it said that, okay, I modified the index.ipynb file, which makes sense. I made a change. I completed my lab. So it says here, the branch is up to date, and I haven't really committed any changes. So whenever you want to take a change from your local machine and push it up to GitHub, there are 3 steps that I always do all together. There's adding, committing, and pushing. So I think I sort of talked about this yesterday, but there are so many steps in place just to make sure that you're not, just saving any change. So GitHub is often used by big companies to store all of their app information and project information. You want to make it not so easy for changes to be made, just in case, just so that no random person can just push changes. So 3 things that we have to do. First, we're going to stage our commit. So staging is the Git Add step. So there's several ways to do this. You can see here, there's Git Add. I like to do Git Add space period. The space period just means everything. So I do Git Add space period, that stages everything. And if I just do Git Status one more time, you'll see that, all right, these are some changes that to be committed. It turns from red to green, and usually that's a good color change sign. So when a change is staged, it means that you intend on making that change. The next step is to commit that change, so you go from staging it to committing it. And when you commit something, you actually have to document what that change is. Of course, it becomes more relevant when you're working on bigger scale projects, but a commit message is something that you always need to have when you're making commits. So here, the next step you do is git commit. So it's git commit, and it's always -m for message. And then in a string, add whatever message you want. Maybe I say completed lab, and it's all in a string. So it's you can put spaces, symbols, whatever you want. So when that's done, you can see that, all right, this file was rewritten because there are some changes there. I do Git Status one more time. You can see that my branch is now ahead by 1 commit. And I'll talk about what all of this means in a bit as well. But then all you have to do is do git push to publish your local commits. So after the commit step, once I do git push, there'll be a little bit of loading. But after this, if I were to refresh this page, and let's wait for it to load. Sometimes GitHub's a little slow with loading. You can see that we have my changes on my labs. You don't have to do this for all of your labs. Maybe if you just want to maybe a lab that you spend a lot of time on that you don't want to lose, I think that's a good way to do it. Also, a good reason to do the commit and push for labs is, let's say this is a very long lab, you're working on it halfway, add, commit, push. Let's say you want to work on it on a different computer. If you want to work on it on a different computer, you can actually clone your half-done lab on a different computer and then finish working on it there. And that's just another perk of having all of your stuff stored on GitHub. So that's just procedurally what's going on. I'm going to draw some pictures and mind maps as to what this process of what we just did was. But any questions at this point? All right, let me share the screen here. I'm going to draw some pics. Okay, hopefully you all see a blank white screen. Okay, so what did we do here? Our lab sort of existed in 3 different places. So first we had the curriculum version, and curriculum version is here. It was the one that had learn co-curriculum / whatever the lab is. It also existed in a version that you forked over. And then I'm just going to call it your remote for now. And I'll explain what remote means. And then after you forked it over, you cloned it. And then your local. So the lab sort of existed in 3 different places. Let me just rearrange this a little bit. Okay. So repositories basically can exist in 2 different forms, remotely or locally. So let's just organize this a little bit better. Everything up here will be remote. Everything down here will be local. So what do we do? The steps that we had was, first we had a fork step. The fork brought it from the curriculum version to your own version. And then we had a clone step, which took the remote version and brought it onto your local computer so you can work on it offline, so on and so forth. After you made changes, what you did was, we did the add commit push. Add commit push. And that updated our remote. If we didn't fork the lab over and we tried to update our changes onto GitHub, you'll actually run into, like, I think it's authentication error because you don't have permission to edit our curriculum, which makes sense, right? Why would they let you have your answers on our curriculum? So that's kind of what happens. This process, this diagram kind of summarizes everything that we just did. Things that we're gonna, just some terminology that we're gonna remember for the next procedure that we're gonna talk about is things exist, remote and local, and then also 2 different users own this. So this is owned by Learn Co, and then this is owned by you. So here's how we'll organize all of, like, the places where material can live. Questions at this point? All right. So next thing we're going to do is we're going to talk about the study group repo and how we're going to work with that. I'm going to clear this. And let me just do that big organization again. So here we have remote, and then we have local, top, bottom. And then with the study group repo, it's owned by me. So there's Ish's version, and then this is your version, student's version. So our repo is going to actually live in 4 places. By the way, I told you all that it would be probably helpful to follow along with the study groups link. I can't have both screens being shared at the same time. So if you have that, like, study group repo pulled up, let me see if I can get that. Yeah, I don't think I can share it right now. But the study group repo, pull that up, and they're basically all the instructions that I'm going to kind of talk about in a little bit. So how the study group repo works, and we're going to do, like, the boxes again. So I basically create the study group repo, and I'm going to keep updating notes on the study group repo. So the study group repo starts off on my local computer. So ish local. So this is where it starts. So I'm creating these study group notebooks, I'm putting them all together. And when it's time for you all to have your study groups, I'm going to put them onto my remote. This process, you guys don't have to worry about because this is what I do. So what you all have to do now is you need your own version of the study group notes, because ideally, if you're using some of my notebooks, you would like to, run the cells, potentially, take notes and comments if you like as well. You're going to make your own changes. So therefore, there's going to be some forking going on. So you're going to have student remote. So if you see, I think the first step of that study group repo says that you should fork the repo first. And this is step 1. So first, you're going to fork the repo so that you have your own version. So in the future, you can store all of your changes that you're making on the study group notes. Something that's slightly different. Before that, you can also then clone it so that you can, open it up on your own Jupyter notebook. Student local. There we go. Step 2 is to clone. Actually, on my notes, it's not step 2, but let's just call this step 1A is clone. There we go. All right, so when I make changes, something that's slightly different is we're gonna have a diagonal line. When I make changes, you're actually gonna get changes from my remote. And that's the part that's, I think, a little bit, what's the word, abstract. You're gonna be pulling changes from here. So later on, we'll see, add remote. You're gonna have to add my remote as a source for you to get changes in the future. This part's a little bit confusing, but all you have to do, you only have to do this one time. And I think I put that in the instructions as well. Just have to type in git remote, add upstream, and then my URL. And so when you do this add remote step, it just tells your repository that future changes, you're going to track the changes of my remote rather than your remote, because your remote's not going to make any changes on its own. Only my remote is going to be. So there's going to be this diagonal line, which there is going to be a couple other lines for every time you update that. But that's kind of what a process. That's kind of what the process is there. Anytime you're working on these study group notes, maybe you're taking your own notes, maybe you're running some of the cells, maybe you're editing some of the code that I had there. Every time you have changes, it's always a good idea to back them up on the cloud. So you're also going to do some add commit push. So I think that I put a step 3, add commit push. That's step 3. Sorry, my handwriting is not great. All right, that's step 3. So great. If you were to do this right now, you should have no problem. What gets a little bit tricky is whenever I make changes, and let's say I add the study group notebooks for next week, how are you going to get them? One way to do is you can reclone the repo, like refork and reclone the repo, but we don't want to do that multiple times. And so there's going to be a couple new things that you can do. First, before you want to retrieve any new notes, to prevent any sort of conflict in material, it's a good idea to make sure that you do this step. It's a good idea to make sure that your own local changes have been added to your remote. After you've made sure you've done that, doing your add commit push, and again, it's the same process as with the labs as well. After you do that, there's a couple steps from getting my remote to your local. So it's steps 2 and 3 from the that I have on the read on the instructions there, but they are basically called fetch and merge. Fetch and merge, and I put the lines of code that you should put in your terminal on the instructions as well. But it is this fetch and merge step that is able to take changes from my remote onto your local. And so I'm able to make changes over and over again over the course of these next 10 months. And as long as you follow this fetch and merge step, and actually as long as you do the fetch and merge, the add commit push over and over again, you'll be able to get the new notes and make changes. Something else that I know there's a lot of arrows here. After you fetch and merge and you have, my new empty study group notes, it's a good idea to also just push them just in case. So I know there's a lot of arrows right now, but that's the last thing that we're going to talk about. This is super, super confusing. I totally recognize that, but if this doesn't make sense, as long as you follow the steps on the instructions, you should be okay. Let me see if I can save this image so I can send this out in a little bit. Okay, there we go. All right, let's go back to my other screen share. Any questions about this? I know this might have been information overload for some of you.
Yeah, is this this is on Canvas, right? Or is this on the
So this So this page here is what is linked here. So if you see here, I've added this today. As long as you click onto study group repo, you'll see all of the instructions here. So I kind of walk through the instructions. So if you're getting this repo for the first time, don't forget to fork it. Unfortunately, I cannot fork my own repo, but you can fork the repo, make sure it is the URL. So I wouldn't copy and paste this. I would just fork the repo and clone it onto your computer. And then right after you fork it, just copy and paste this line. And this line is basically what tells your repo that future changes are going to come from my version. And then again, you're going to do your add commit push just to make sure that your changes are saved. And then what I was talking about with the later half of the red arrows, if you want to fetch any changes from my version, you have to do 3 steps really. Fetch your upstream, git fetch upstream, merge it with your own stuff. And here you actually have to do a commit message as well. And then that's how you get your changes. So as long as you follow these steps the first time you're doing it, and I do recommend that maybe you all try it this week. If you have any issues, let me know. And then early next week, or actually, no, probably at the end of the week, this week, I will add the notebooks for next week. I'll let you all know when that is up, and then you can try these steps to see if you can get those updated notebooks. Questions so far? All right, good use of reactions. Okay, let's see. Oh, several things to remember. As you're deciding, where should I put the study group repo and all of that. Hold on, let me just clear this. By the way, if your Git bash or your terminal is very, very cluttered and you want to reset it, I think it's Control K. I forget, I don't know if Windows is exactly the same, but I think Control K should clear your terminal screen or your Git bash screen. And then if I do just CD without any file name or without any periods, it actually brings you back to your root directory. That's sometimes also handy. Some tips and tricks. Don't ever clone a GitHub repository inside a GitHub repository. And how you know if something is a GitHub repository or not, if you do Git Status is something that really just checks the status of your repository. It's not doing any action, so it's kind of a safe command. I do Git Status, and if it's not a Git repository, it just says that it isn't one, which in this case, I don't want it to be. Just an example, let's see, I think I have our study group notes here somewhere. Okay, so I already cloned this on my own computer. Mine's a little different from yours because I'm the one that gets to update this for you all. But just to show you all, what does it mean to be a Git repository? And how does your computer know when something is a Git repository? If I do Git Status, great. It says that it doesn't give me the error that it isn't one. So it is one just by, what's the logic? Whatever, yeah. So it is a Git repository. How does something know it's a Git repository? One, when you clone anything from GitHub using git clone, it actually creates some secret files. So if I do ls here, you can see that I have the README in phase 1, which is the same as what's showing up here. There's something called secret files, and I don't know if anyone's aware of secret files, but any file name that begins with a period is a secret file. And the way to see these secret files in your terminal, you don't have to do this all the time, but it's just sometimes good to know. If I do ls space -a, it'll actually show, these files like README in phase 1, but it'll also show all the secret files as well. The file that indicates to your computer whether something is a Git repository or not is this .git file. We can actually open this up to see what it is. It really just tells you, the information of your GitHub repository. You should not touch this or edit anything because it might mess up how your repository interacts with GitHub. But just so you all know, as long as there's a .git file or folder in the repository, that's how your computer recognizes that it is a Git repository. And this is something that's automatically created when you git clone any repository. So if you are worried about doing the cardinal sin of cloning a repository inside a repository, so never do that. That's one way that you can check. Something else that I wanted to talk about that we will actually get into a little bit more when we get into projects is Git Ignore. So I think every lab actually has this Git Ignore file. I even have this here in the study group repo. And if we open it up, I mean, I can open it here. I can also open it in my terminal, but you basically see like a bunch of like file names. I don't know if any of you have seen these so far, but some that might be familiar. If you're working on your notebook, let me see. I hope this is not too small. All right. There's like IPYNB checkpoints. Another one that's pretty common is like DS store. I know that like comes up on in a bunch of computers sometimes. These are, yeah, I think DS store is something that's like automatically generated as like a cache. I don't know anything about that side of computer science, but yeah, these are kind of like automatically generated files. Checkpoints. There's one more called PyCache. Whatever. Yeah, PyCache here. What these are doesn't matter. But what a Git Ignore is that you see how, and let me just zoom back out again. So you see how when I did ls-a, there was like .git, .gitignore. Sorry, there's like .git. And they're like these, like, I don't know what those are. But basically, what a Git Ignore does is any file that is listed in the Git Ignore is not going to be pushed up onto GitHub. One common use case of this, and we'll actually get into this when we get to topic 9 towards the end of the phase, is let's say you want to store your password on in this repo somewhere. So I store my password in like a password text file, for example. And of course, I don't want my text file with my password to be published onto GitHub. If I don't want that to be published, and if I don't want that to be automatically pushed up to GitHub when I do like add commit push, one way to get it to automatically disregard that file pretty much is to add that file into the Git Ignore. We're actually going to be doing some of that when we get to the towards the end of the phase. So no worries about that if this doesn't make sense yet. But just in case you're curious, if you're curious what Git Ignore is for. Any other questions at this point? All right. We can get a little bit more advanced. With these branches here, oops, this one doesn't have branches. Where is our repo here? So with these branches here, you can actually access them on through your terminal as well. Likely you won't have to do this. So let me go back to that other lab from earlier. So CD, where did I put it? DS labs. I think it's DSC, what, strings lab? Okay. So here I'm in the strings lab. Let's say I just want to look at the solutions locally for some reason. One way to do that, and this is something that you don't have to remember for now for sure, but one way to do that is git checkout solution. Wait, let me just double check. Is solutions with an S or without? Okay, without an S. So if I do git checkout solution, you can see that it switches to a new branch solution that tracks the remote branch solution. Now when I launch Jupyter Notebook, and I go into the index, it should have my solutions all there. So just in case for some reason, if you want to access your solutions on your local Jupyter Notebook, that's one way to do it. I will say it gets very, very tricky because right now the repo is on the solutions branch. So you just have to be very careful because, I don't know, you cannot have both versions open at the same time. So yeah, I exited that out. And yeah, cool. I think that's pretty much all I had to share with regards to Git. Hopefully this kind of helped with, you know, demystifying all of the things within Git. I know that in like the phase 2, they go through like a good bit of stuff. Let's see, in topic 2, I mean. So there's a bunch of stuff here. Like they talk about merge, stash, I would say with this stuff, you don't have to worry about too much for now. We will get some hands-on experience working with this stuff when we get to our project. But yeah, any questions about anything we've talked about so far? Perfect. Well, that's all I had to share for today. I'm going to stop the recording right here.